Are we truly alone in the universe? It's a question that's haunted human imagination for centuries, drifting through ancient myths, modern science, and everything in between. From cave paintings that some interpret as otherworldly encounters, to radio telescopes scanning deep space for signals, our curiosity has only grown stronger with time. This single mystery has sparked entire fields of study and countless scientific missions. Even the greatest minds, from Galileo to Hawking, have wrestled with this cosmic enigma. The very idea of other intelligent beings living somewhere beyond Earth drives our questions, our technology, and our sense of cosmic purpose. And while the universe is vast, unfathomably vast, some scientists are now shifting focus to something slightly more approachable: our own galaxy. Because when you take a step back and really consider just how unimaginably big the universe is, filled with an estimated 2 trillion galaxies, it almost becomes overwhelming to think about searching for life everywhere. Each of those galaxies could hold billions of solar systems, each with their own array of planets. So instead of asking whether we're alone in the universe at large, many researchers now ask something slightly more manageable. Are we alone in the Milky Way? After all, our galaxy alone contains about 400 billion stars, many of which are orbited by planets. And in recent years, thanks to increasingly advanced telescopes and satellite missions, we've been able to detect thousands of these planets, some of which may even be Earth-like. That shifts the conversation from speculation into something grounded in real data. One fascinating recent development comes from researchers at the University of Nottingham, whose work was published in the Astrophysical Journal. Their study suggests that the Milky Way might actually host at least 36 intelligent alien civilizations capable of communication. That number may sound oddly precise, especially when compared to earlier theories, but the scientists behind the study say their estimate is intentionally conservative. They based it on several carefully chosen assumptions, designed to mirror the conditions that led to intelligent life on Earth. Their guiding principle? That Earth is not unique or special, just one of many planets where life could have evolved in a similar way. If life happened here, under a certain set of conditions, why couldn't it happen somewhere else under the same conditions? To understand how they got to the number 36, we need to look at how they approached the math. The researchers started by assuming that intelligent life takes around 5 billion years to evolve, just like it did on Earth. Then they imagined that other Earth-like planets orbit stars similar to our Sun, under similar conditions. From there, they calculated how many of those planets might develop technologically advanced civilizations capable of emitting signals into space. Based on these parameters, they concluded that the number of likely communicating civilizations in our galaxy could range from as low as 4 to as many as 21, with 36 being the most statistically probable. And even this might be a low-end guess, since it assumes civilizations only last a few hundred years before either evolving past communication or disappearing entirely. This estimate marks a huge improvement over older models, like the famous Drake equation, which was developed in the 1960s to estimate the number of intelligent civilizations in the galaxy. That equation includes 7 variables, such as the rate of star formation, the number of habitable planets per star, the fraction of planets where life emerges, and so on. But the big problem with the Drake equation is that many of its inputs are educated guesses at best, and complete stabs in the dark at worst. Depending on what values you plug in, it can give you wildly different answers, anywhere from 0 to several billion civilizations. The new method aims to reduce that uncertainty using better observational data and more cautious assumptions, yielding a more refined and grounded estimate. Still, even if there are 36 civilizations out there, the challenge isn't just knowing they exist, it's actually finding them. The distances involved are staggering. If those alien societies are spread evenly throughout the galaxy, they could be separated by thousands of light years. That's far beyond the reach of our current technology, and even sending a message would take millennia to arrive, let alone getting a reply. So instead of trying to communicate with civilizations halfway across the galaxy, scientists are increasingly looking closer to home. That's where Proxima Centauri b enters the conversation, a nearby exoplanet that may be one of our best chances to find life outside Earth. Proxima Centauri b orbits the star Proxima Centauri, which is just over 4 light-years away from us. That makes it the closest known exoplanet in another star system. What makes it even more exciting is that this planet lies in the habitable zone of its star. This so-called Goldilocks zone refers to a region where temperatures are just right, not too hot, not too cold, for liquid water to exist on the surface. And since liquid water is considered essential for life as we know it, Proxima b becomes a prime candidate for further study. This one planet alone offers the tantalizing possibility that alien life might be closer than we ever imagined, practically next door in cosmic terms. In terms of physical characteristics, Proxima Centauri b is also intriguing. It has a mass of approximately 1.17 times that of Earth, meaning it's only about 10% larger in diameter than our home planet. That makes it what astronomers call a rocky planet, likely with a solid surface, rather than a gas giant like Jupiter or Saturn. But one thing sets it apart significantly: the planet is likely tidally locked to its star. This means that one side of the planet always faces the star and basks in perpetual daylight, while the other side remains in eternal darkness. It's the same gravitational effect we see with the Moon and Earth. Our Moon is tidally locked too, always showing us the same face. This unique condition could create three very different climate zones on the planet: a scorching hot day side, a freezing cold night side, and a thin sliver of moderate temperature in between, known as the Terminator Zone or Twilight Belt. This middle region, caught between extremes, may offer the best chance for habitability. There, temperatures could be stable enough to allow water to exist and life to take root. Imagine a thin strip of perpetual dusk stretching around the planet, where alien organisms might thrive in a strange balance between light and darkness. Now, if life has evolved on Proxima Centauri b, it would have adapted in extraordinary ways to its environment. On the sunlit side, life forms might have evolved biological shielding mechanisms to protect against constant radiation, or even developed advanced ways to harness energy from the constant sunlight, much like how plants perform photosynthesis on Earth. On the dark side, where temperatures plunge and light never reaches, life may rely on geothermal heat from within the planet or perhaps even chemical energy sources similar to the ecosystems found near hydrothermal vents deep in Earth's oceans. These life forms might look nothing like anything we've seen, perhaps bioluminescent, heat-sensitive, or completely dependent on environmental energy sources we barely understand. But let's stretch our imagination further. What if intelligent life exists on Proxima Centauri b? The implications of that would be absolutely staggering. For one, it would mean that we are not alone, not even in our own galactic neighborhood. And if life has emerged independently so close to us, then life might be common across the galaxy. Think about the odds. With 400 billion stars in the Milky Way, what are the chances that the only two intelligent civilizations happen to be orbiting stars just 4 light-years apart? It would suggest that intelligent life doesn't just emerge, it's practically inevitable under the right conditions. Moreover, the existence of intelligent beings on Proxima Centauri b could offer huge insights into the possibilities of space travel. If they're advanced and haven't contacted us, it might mean that interstellar travel, even over short distances, is a serious barrier even for intelligent civilizations. On the other hand, maybe they're not as technologically developed as we are. If that's the case, then we could be the first ones to reach out. Imagine that for a moment, humans becoming the visitors, the explorers, the ones making first contact with an alien species. In that moment, we become the aliens, landing on someone else's world, a role reversal that forces us to rethink our place in the cosmos. Of course, before we let our imaginations run too wild, we must remember that all of this is still highly speculative. As of now, we have no direct evidence that life exists on Proxima Centauri b, or anywhere else beyond Earth. But that doesn't stop scientists from looking. In fact, the mystery only drives the search harder. Every telescope we launch, every exoplanet we discover, every signal we scan through, brings us closer to either the truth we hope for, or one we've yet to imagine. One of the most intriguing exoplanets in our ongoing hunt for alien life is Kepler-62e, a super-Earth located roughly 1/200 light-years away in the constellation Lyra. What makes this planet particularly compelling is its size, about 1.6 times the radius of Earth, which implies it could have similar gravity and potentially Earth-like atmospheric pressure. It orbits a K-type star, which is cooler and smaller than our Sun, but importantly, Kepler-62e lies well within the habitable zone. That's the sweet spot where conditions might allow liquid water to exist on the surface, an essential ingredient for life as we know it. Scientists believe there's a strong chance that Kepler-62e could be what's known as a water world. This would mean the planet might be completely or mostly covered in vast, deep oceans. And where there's water, there's always the tantalizing possibility of life. If aquatic life has indeed taken root there, it could range from simple single-celled organisms to complex, even intelligent marine species. This raises fascinating possibilities about how evolution might occur in such a water-dominated environment, and how communication, tools, or civilizations might develop underwater, if at all. If Kepler-62e has an atmosphere, scientists speculate that it might be thick, humid, and cloud-covered, possibly wrapping the entire globe in a dense, misty shroud. This kind of greenhouse-like atmosphere could help keep surface temperatures relatively warm, even extending warmth toward the polar regions. While such an atmosphere might make Earth-like land civilizations difficult to imagine, it wouldn't necessarily prevent life from evolving. Marine life, adapted to warm, wet, and dark environments, could thrive beneath the waves in ways we can't even begin to comprehend based on Earth's biology alone. Despite its potential, Kepler-62e remains a mystery. Its distance, over 1,000 light-years away, means it's far beyond our current technological capability to observe in detail. We can't yet see its oceans or study its atmosphere directly. All we have are the precious signals and data collected by telescopes like Kepler and later confirmed by follow-up observations. But even with such limited information, this exoplanet is considered one of the best candidates for alien life in our galaxy. If there is life out there, Kepler-62e might be one of the places it's hiding, quietly evolving beneath endless alien seas. Now let's turn our attention to another captivating world, Gliese 667cc, sometimes shortened to GJ 667cc. Located just 23.6 light-years away, this exoplanet is also a super-Earth, with a radius about 1.7 times that of our planet. What sets Gliese 667cc apart is not just its size or location but the fact that it resides in a triple-star system. If you were standing on its surface, assuming that's possible, you might see 3 suns rising and setting across its sky. That alone gives this world a surreal, almost science fiction-like allure. The planet orbits a red dwarf star called Gliese 667c, which is much smaller and cooler than our Sun, about 1/3 its mass. But here's the exciting part. Red dwarfs like Gliese 667c can burn for up to 150 billion years, which is more than 15 times longer than the Sun's expected lifespan. That kind of cosmic longevity offers a dramatically extended window for life to take root and evolve. Even if intelligent life hasn't emerged yet on Gliese 667cc, the system will be around for billions of years to come, giving evolution plenty of time to work its magic. Gliese 667cc is just one of at least 6 planets orbiting its red dwarf star, and 3 of these planets lie within the habitable zone. This means it's not just a single world with potential, it's an entire system that might be teeming with life-bearing candidates. If life can develop in such systems, it's possible that microbial ecosystems, or even complex biospheres, exist across multiple planets, increasing the odds of encountering alien life in that neighborhood. It's almost like nature rolled the dice multiple times in the same solar system, giving life more than one chance to arise. However, as with Kepler-62e, the lack of direct imaging means we don't yet know for sure what's happening on Gliese 667cc. Is it a rocky world with oceans and an atmosphere, or something entirely unexpected? Is its climate stable? Are conditions suitable for complex biology or even intelligent life? These are the questions scientists are eager to answer. With future telescopes like the James Webb Space Telescope and others yet to be launched, we may one day be able to peer deeper into systems like Gliese 667 and confirm whether these promising worlds truly host alien life, or remain fascinating lifeless orbs. Let's move now to another gem of the Kepler mission. Kepler-22b***, a super-Earth about 2.4 times Earth's radius. This planet orbits a Sun-like star approximately 640 light-years away and lies well within its star's habitable zone. However, the composition of Kepler-22b is still a matter of scientific debate. Some researchers believe it could be a massive rocky planet, while others suggest it might be an ocean world, potentially covered in liquid water from pole to pole. There's also a chance it might even be a mini Neptune with a thick gaseous envelope, though that would make it less hospitable. If Kepler-22b does turn out to be an ocean planet, it opens up intriguing possibilities. Life could exist beneath the surface in watery environments similar to Earth's deep oceans. Think about the life that thrives around hydrothermal vents on our ocean floors, creatures that live without sunlight, sustained only by chemical energy. Something similar might be occurring on Kepler-22b. In such a setting, alien organisms could evolve in total darkness, relying on chemical processes unfamiliar to earthly biology. These environments could also host ecosystems so different from ours that we may not even recognize them as life at first glance. But here's a fun mind-bending detail. If an advanced civilization were living on Kepler-22b right now, looking at Earth through a powerful telescope, they wouldn't be seeing our modern world. They'd be watching Earth as it was in the year 1384, the time of medieval kings, castles, and plagues. That's because the light from Earth takes 640 years to travel to Kepler-22b, just as their light takes the same amount of time to reach us. This time lag reminds us that astronomy isn't just about distance, it's also about time travel. Every star, every world we look at shows us a piece of ancient history frozen in time. Even though 640 light-years feels unimaginably far, it's actually a tiny slice of our galaxy. The Milky Way is over 100,000 light-years across, which means Kepler-22b is less than 1% of the way across the galactic disk. That's mind-blowing. When we put that into context, we realize how small our current exoplanet searches really are. So far, we've only just scratched the surface. Based on data from the Kepler Space Telescope, scientists estimate there could be as many as 300 million potentially habitable planets in the Milky Way alone. That's not just a few lucky finds, that's an entire hidden galaxy of Earth-like possibilities. Now, consider this mind-altering idea. What if each galaxy in the universe hosted just one intelligent civilization? Just one. That sounds extremely conservative. But with an estimated 2 trillion galaxies in the observable universe, that would still mean there are 2 trillion civilizations out there. Even if 99.9999% of them are primitive or extinct, there could still be millions of intelligent species coexisting across the cosmos, each shaped by unique environments, cultures, and evolutionary paths. The silence we hear in our skies might not mean we're alone, it might mean we're just listening at the wrong time or in the wrong way. When we reflect on numbers like that, it's hard not to feel small. We're a tiny speck on a tiny planet, orbiting an ordinary star, tucked into a quiet arm of a spiral galaxy among trillions of others. But rather than feeling insignificant, we might feel inspired. Our place in the universe might be small, but our curiosity is enormous. We've reached out with machines, signals, and telescopes in hopes of making contact. And in doing so, we've revealed just how vast and mysterious the universe really is. Each exoplanet we find, like Kepler-62e Gliese 667cc, or Kepler-22b, is a potential mirror, showing us what might have been or what could still become. So as we gaze out into the stars, we should keep asking ourselves, what legacy will we leave behind? What will the universe remember us for? Will we one day be the explorers who reached across the stars? Or will we remain a quiet mystery, never discovered, never known, drifting unnoticed through the infinite sea of time and space?